Welcome to the DIY Honda Garage channel. In this presentation, we will be troubleshooting the DTC or Diagnostic Trouble Code P0113, which indicates a high voltage condition in the intake air temperature IAT sensor circuit. The IAT sensor plays a crucial role in monitoring the temperature of the incoming air for proper engine operation. It's typically located near or integrated with the mass airflow (MAF) sensor in your Honda Odyssey. Understanding this diagnostic code is essential for maintaining engine efficiency and performance. We will explore the components affected, possible causes, symptoms, and a detailed troubleshooting process to identify and rectify the problem. Let's dive into the specifics of the IAT sensor and its functioning within the vehicle system. The DTC P0113 refers to a problem associated with the intake air temperature IAT sensor circuitry, which is responsible for measuring the temperature of the air entering the engine. This sensor is typically located near the mass airflow (MAF) sensor, working in conjunction with it to ensure that the engine management system has accurate data to optimize the air-fuel mixture. A high voltage in the circuit indicates that the readings could be erroneous, often leading to improper engine performance and fuel efficiency. Should the IAT sensor report temperatures such as -40 degrees Fahrenheit or a voltage reading above 4.92 volts, it indicates a failure within the sensor circuit. Addressing this error is essential, as the engine relies on accurate air temperature readings to adjust ignition timing and fuel delivery, ensuring optimal performance. Understanding the possible causes of the DTC P0113 helps technicians narrow down the issues effectively. A faulty IAT sensor is a primary suspect, as it may provide inaccurate temperature readings due to internal failure. Wiring issues can also disrupt the connection, leading to high voltage due to poor insulation or damaged wires. Additionally, a bad connection to the powertrain control module (PCM) could impact the performance of the IAT system by preventing clear data transmission. Corrosion or grime on sensor terminals can add resistance, resulting in erroneous voltage levels. Diagnosing these potential causes is vital for pinpointing the exact fault affecting the IAT sensor operation. The symptoms associated with DTC P0113 can significantly affect the driving experience. One of the most noticeable symptoms is poor engine performance, as the engine may struggle to adjust the air-fuel mixture correctly without accurate temperature readings. Increased fuel consumption is common, since incorrect readings can lead to an overly rich or lean mixture. The check engine light, CEL, being illuminated is a clear indication that the onboard diagnostic system has detected a problem requiring attention. Additionally, drivers may experience some difficulty starting the engine, especially during extreme temperature conditions, as the sensor fails to provide accurate data right from the start. Recognizing these symptoms helps in identifying the need for immediate diagnostics and repairs. The first step in troubleshooting DTC P0113 is to turn the ignition switch to the on position without starting the engine. This allows the onboard diagnostic system to power up and run necessary checks. Next, use the Honda Diagnostic System HDS to view the IAT sensor data in the data list. You are specifically looking for extreme temperature readings, which could be around -40 degrees Fahrenheit or less, or a voltage reading of 4.92 volts or more. If either of these conditions is present, it's a strong indication that the system is detecting an abnormal state. If normal readings are found, this suggests an intermittent failure, and it's important to check for poor connections or loose terminals at both the MAF sensor, IAT sensor, and the PCM. In the second troubleshooting step, you will first turn the ignition switch to the lock, 0 position, to ensure the safety of both the technician and the vehicle's systems. Afterward, disconnect the MAF sensor/IAT sensor 5P connector to perform further diagnostics. It's crucial to then connect terminals number 4 and 5 of the 5P connector using a jumper wire. This jumper will effectively bypass the IAT sensor and allow for a direct test of the circuit. This step helps isolate the problem by highlighting whether the issue lies with the sensor or the associated wiring and connections. Ensure that the connections are secure to avoid inaccurate readings. With the jump wire in place, turn the ignition switch back to the on second position once again. This will enable the HDS to assess the state of the IAT sensor data in this newly configured circuit. Just like in the previous steps, you need to look for abnormal values, specifically any readings at -40 degrees Fahrenheit or lower, or a voltage level exceeding 4.92 volts. If these readings persist, it suggests that a problem may not solely reside with the IAT sensor, indicating deeper electrical issues are present. Confirming that the problem is indeed systemic helps guide further troubleshooting practices and narrows down potential faults accurately. Once Step 3 is complete, and if extreme readings were found, turn the ignition switch to the lock 0 position again for safety. Subsequently, remove the jumper wire that connected terminals number 4 and 5 at the MAF IAT sensor connector. After removing the jumper, turn the ignition switch to the on 2 position one last time. At this point, the multimeter will be used to measure the voltage across terminal number 4 of the 5P connector and body ground. This measurement is crucial as it further assesses the circuit integrity by determining whether the voltage aligns with expected performance levels. Any significant discrepancy in these readings either indicates further wiring issues or a potential fault within the powertrain control module, PCM. After addressing the issues found during troubleshooting, it's essential to perform a final verification to ensure that repairs have been successful. Start by rechecking the IAT sensor data to confirm that the readings fall within normal operational ranges without any extreme values. It is also critical to ensure that all connections are secure and free of corrosion or damage, as these can lead to intermittent issues. Once these steps are completed, clear any diagnostic trouble codes from the vehicle's memory using the HDS and perform a test drive. During the drive, monitor the performance of the vehicle to ensure that the repair efforts have led to the desired results and that the vehicle operates smoothly without any check engine light illumination. In conclusion, the IAT sensor plays a vital role in your Honda Odyssey's overall performance by ensuring accurate air temperature measurements for effective engine operation. The DTC P0113 signifies a high voltage condition in the IAT sensor circuit, indicating a system fault that merits careful attention. It is imperative to follow each troubleshooting step methodically to accurately diagnose and rectify the issue. By ensuring thorough checks at the end of the diagnostic process, we can confidently return the vehicle to optimal operation, preventing future breakdowns and maintaining fuel efficiency. Remember, regular vehicle maintenance, including electrical systems checks, can help in avoiding such issues down the road. Please like and subscribe to the channel. See you next time.